Hello students, so continuing our lectures on mathematical physics and especially the statistical distribution, we'll start our discussion by talking about something called a moment generating function. These are MGF. Now an MGF can be defined mathematically as E into e to the power x minus mu into t, and where it is equal to e, we expand this exponential, it will be 1 plus x minus mu t plus x minus mu square t square by 2 factorial, and it will keep on going like that. So that is again equal to 1 plus 0 plus coefficient of mu2 t square by 2i 2 factorial plus a coefficient called mu3 into t cube by 3 factorial, so on and so forth. Mu n is the nth moment about the mean is the coefficient of t to the power n by n factorial. So this is moment generating function MGF. The next topic that we will discuss is propagation of errors. Now, if an error on the measurement of f x y, if the error is sigma f, and the error that on x is sigma x and that on y is sigma y respectively, then sigma x and sigma y are correlated. And if sigma x and sigma y are not correlated, then we can express a sigma f as equal to del f by del x whole square into sigma x square plus del f by del y whole square into sigma y square, and so on. Thus we can say that if f is equal to x plus minus y, then sigma f will be equal to sigma x square plus sigma y square 3 power 1 by 2, and if f is equal to x by y, then sigma f by f is equal to sigma x square by x square plus sigma y square by y square to the power 1 by 2. So this is how the propagation of errors function is. The next topic is least square effect. Now if we have a straight line, y is equal to mx plus c, it is desired to fit a pair of points, it is x1, y1, x2, y2, and xn, yn by a straight line. So if that is the case, then we have a quantity called the residue S, which is equal to summation I is equal to 1 to n yi minus mx I minus c whole square. So if we minimize the residue, that means if we take del s by del m as equal to 0 and del s by del c is equal to 0, then the normal equations are, get some normal equations, that is m sigma I is equal to 1 to n xi square plus c summation I is equal to 1 to n xi minus summation I is equal to 1 to n xi yi is equal to 0. Let me write it once again. We get two normal equations. First equation is m summation. By summation, it automatically means we are doing it for 1 to n. The summation m xi square plus c summation xi minus summation xi yi is equal to 0. This is the first normal equation. And the second normal equation is m summation xi plus nc minus summation yi is equal to 0. So these two are involved by doing the minimization. That is, the first one is del s by del m is equal to 0. We get this first normal equation, and for this one we get do del s by del c is equal to 0. Then we get the second normal equation. So which are solved as ordinary algebraic equations to determine the best of m and c. So this is called the least square fit. So the same thing can be done also for another type of curve. So we have used a straight line here. It can also be a different curve. For example, it can be a parabola. So if it is a parabola, having the equation y is equal to a plus bx plus cx square, then again the residue s is equal to summation yi minus a minus bxi minus cxi square whole square, and we minimize the residue, minimize s. So we have by three different ways. First of all is del s by del a is equal to 0, then del s by del b is equal to 0, and then del s by del c is equal to 0. So for these three minimizations we get three different normal equations. First one is summation yi minus na minus b summation x minus c summation x I square, all these are I, is equal to 0. This is for this one. For the second minimization condition, that is when it is doing with respect to b, we get summation xi yi minus a into summation xi minus b into summation xi square and minus c into summation xi cube is equal to 0. And the last one, for delta s delta c is equal to 0, we get xi square yi minus a summation xi square minus b summation xi cube minus c summation xi to the power 4 is equal to 0. So three normal equations we get, which we solve to find the value of a, b and c, which is the best fit.